Tina Kato. Good morning, everyone. Welcome again to our webinar today. Early warning system has been a key element for disaster risk reduction. And through this Sendai framework, it also created that warning system is important to managing your risk and reducing your disaster risk reduction. We have today 3 speakers for this webinar. Andrew McCoy from UNDRR. Unfortunately, he is having difficulties to joining us through internet systems. We have Sir Peter Gluckman, Director, COI2, Center for Informed Future. We have Georgina Griffith, meteorologist from New Zealand Met Services, and myself, Bakun Fakhruddin, working in Tonkin and Taylor, New Zealand. It's just a great pleasure to see that each of those continents, even though it's a morning, night, and afternoon times, but join to this session. We have almost 300 subscribers today for this webinar. So with these things, I'd like to invite our first speaker, Sir Peter Gluckman, the director going to the Center for Informed Future, to discuss about about policy and political situation for early warning system and disaster risk reduction. Thank you.
Thank you, Bapon. I'm a former Chief Science Advisor to the Government of New Zealand, and so what I wanted to talk about for a few minutes is my impressions for why the public sector does not prepare well for rare but forecastable events. I think while I focus on the public sector, I think the comments also apply in much of the private sector as well. When we're dealing with rare but forecastable events, it's important to think about the fact we know these events will occur, we just don't know when they will occur. And the issue, of course, is formulated more within risk assessment practices, where we are in general very good at identifying hazards, their likelihood and their impact. But the issue is, how do we persuade the country or the organization to invest in the necessary better understandings of the hazard through science and technology, investing in sensors, if in the case of a natural hazard, to identify when the hazard may turn into an absolute risk, or the use of modeling, which I know the next speaker will talk about in more depth, where models can help also identify much about it. And of course, it's all very well to know the event is going to occur, but the key issue from a public policy point of view is often the level of resilience preparation that one undertakes, the level of investment one takes, both in terms of preparation, in identifying when the risk might occur, such as through sensor investment, but also in terms of the amount of resilience preparation and investment one makes. Oops, we've just lost the slides. What's happened to the slides? Here we are. The basic tool, of course, is the risk register. It's a basic record of risk assessment and preparation, extensively well used in the private sector, much less used within the public sector, perhaps because in the private sector, the liabilities for not identifying and management risk are very clear to the board of directors and to the management, whereas the liability is less certain in the public sector often. The issues that lead the public sector often not to prepare well are generally not technical. They're largely those of communication between the experts and the policy community and the political community, and that interface between evidence and policy is complex. Then, of course, you have the interface between the policy making and the political interface. Then we have to remember that all the decisions being made are being made in the context of individuals and ultimately the political risk that individuals face. And so why do public registers, risk registers, get ignored? First of all, not many countries have them. New Zealand does have one, but it's not in the public domain. And you might ask, why not? Because if it's in the public domain, then everybody will be accountable that the actions suggested in the risk register might get followed. But if it's not in the public domain, the issues of accountability are blurred. The European Union, in contrast, has mandated public risk registers. And again, within the public sector, my experience is that post-event assessment is really used as a learning experience and is largely used in the terms of trying to manage the political risk associated with a hazard, with an event, rather than being used to learn for next time. So why are risk registers problematic in the public sector? The first is, I think, for those who are not risk professionals, risk registers can be confusing and overwhelming. Certainly when politicians see a risk register, they can perceive a risk as being incredulous or overstated. They think that sometimes experts cry wolf too often. And it can become very difficult when you're dealing with a major event which has not occurred in one's lifetime, but can be anticipated, such as a major space weather event for which there's a 10% risk per decade of a Carrington scale event occurring. And therefore, there's issues of communication, of the frequency and impact assessments can be very difficult. And as I've said before, if a risk register is assumed to provide guidance and accountability, it can be seen by the politician as a politically risky document. And of course, in the real world of democratic politics, the political overlay on the politician can often outweigh the risk communication that occurs. Politicians tend, by definition, to focus on the short term. For them, the horizon is always the next electoral cycle. And there's always the more pressing question. There's a limited bandwidth. If there's issues that need to be addressed today, then you can always delay till later issues that may not occur. And prevention gets no political credit if it's never needed. And so there's always the opportunity to procrastinate for rare but major events until they've happened, and then it's too late. And then on top of that, we need to remember that all of us have cognitive biases. We tend to be myopic. We tend to focus more on the short term than the long term. We tend to all forget the lessons of the past disasters, and this is particularly so within the policy and political community. There is an inertia. We tend to prefer in the political community to return to the status quo. And as a species, we're rather good at rewarding people who fix problems, but rather terrible at acknowledging a problem averted. And so we're all focusing now on countries such as New Zealand that have done a good job in preventing COVID or reducing the impact of COVID. We've perhaps not thought about all the many other times that the policy community and the scientific community have prevented epidemics from happening. And so with that, I'll just end my remarks by saying there are many real politic issues in communicating risk and actions on risk to the public, to the policy community, and particularly to the political community. And that needs to be talked about. It's never just a simple technological discussion. It's always a much more complex matter of dealing with cognitive biases and political realities. Thank you very much.
Yeah, good afternoon, everybody. And my sincere apologies for being unable to connect at the beginning for technical reasons beyond my limited capacity to resolve. But my name is Andy McElroy, and I'm the Pacific representative for the United Nations Office for Disaster Risk Reduction based in Suva, Fiji. So the original plan was for me to welcome you, and Bapon, thank you for taking over at the last minute. And terrific that we kicked off today's discussion with some genuine insights from Peter in terms of the importance of connecting with two very different universes, if you like, the technical and policy community, both with a real key role to play in terms of being more effective in terms of our medium range hazard warning systems. So just while we wait to see if Georgina is able to join us, there's 3 points that I would like to make as part of the discussion. And it all relates to the Sendai framework for disaster risk reduction, which is already 5 years old, but whose messages really stand as important today as they were in 2015. And that is that as we face an increasingly complex environment where risk is more systemic, we do need national governments to remain in the lead, but it's clear they cannot do it on their own. And the more we can mobilize an effective and coordinated all of a society approach, then the better. The second point is really, we still have some way to travel in terms of deepening and applying our understanding of risk and having associated governance systems that are fit for purpose to enable us to address this increasingly hazard environment that we face. And then finally, more specifically to today's discussion, early warning, early action is a key pillar of all risk reduction efforts, and we're seeing that more and more, particularly in this era of escalating climate and disaster risk. So let's just see with those remarks from my side, and thank you again, and apologies to join so late. Georgina, are you able to talk with us now? Over.
Well, my mic was working fine when I joined, so I've rejoined. How's my levels?
Coming through loud and clear now. Thank you.
Excellent. Sorry about that, team. Okay, so yes, I'm Georgina, obviously technically challenged forecaster working at Met Service. We're the National Weather Service, so I just wanted to touch on just a key concept today. Okay, so ensemble forecasting, we're looking in the medium range, so days 1 through 14, and this feeds into just a bit of a wrap around where Met Service and forecasting is, about how you get into that longer range window safely and with accurate information. So the first concept I wanted to bring to the table is the concept of ensemble forecasting. When you run a weather model at analysis time, at initialization, there'll always be some error there. And as the weather forecast model is run, those errors grow and grow. At a certain point, the forecast uncertainty is so large that your forecast is effectively useless. For example, if I look at one weather model in time, the red X, and I end up with a forecast of a certain sort of weather at my place for me, that's useful information. But if you go beyond about day 5, 6, or 7, you don't know if that forecast is any good. Okay, those errors might be so large that you've got zero skill. So you might go onto the internet again and find another weather model, and it comes up with quite a different looking possible future or forecast for your place at for the same day. And you're thinking, gee, got 2 different answers. How do I know what's going on? Which one do I trust? So you badly go on the internet again and dredge up some random weather model, and you end up with the yellow cross, which says really extreme solution, the weather on the day that you're worried about is really terrible. So, and then you're very uncertain. You do not know what the forecast is. So how do you know if any model is better than the other? How do you know which one's going to be right? How do you know which one's totally out to lunch? And the answer is you don't. Running a single weather model on the internet or anywhere else beyond about days 5, 6, 7 in the Southern Hemisphere is a waste of time. So given that we're talking about early warning systems in the 10 to 14 day window, how do you do it? And the answer is quite simple. Here at Met Service, and in fact at any National Weather Service, we use ensemble forecasting. So that's using the errors at analysis time in a very clever way. What we do is run a group of models, an ensemble, and shuffle the models around with a bit of error around that, analysis time, what the atmosphere is doing right now. You give them error and you shuffle them around and say, go for it, run out for quite an extended period of time. And that gives you viable and accurate information. An example of these, just ways to use ensembles for a probabilistic approach in the 0 to 14-day window. I mean, the obvious one is the high impact, low certainty event, which is the tropical cyclone, top left in this panel. This is a tropical cyclone that formed in the Southwest Pacific, and this happens to be the ECMWF tropical cyclone track forecast. The EC runs 51 member models in its ensemble, and of course for us here in New Zealand, we were interested in beyond day 5 whether it was likely to come out of the tropics. And actually 85% of the ensemble members in this particular model run showed that it stayed over the coral sea and did not come out of the tropics, and only about 15% of the models tracked it in northern New Zealand. Now, even though we're looking far beyond the window or the horizon that a single weather model can achieve some accuracy, that itself, the 85, 15% split in outcomes, is useful information for us to use. I've also put on another couple of examples about what ensemble forecasting information looks like in the 14-day window. I've got on the right-hand side an accumulated precipitation forecast for a hydro storage lake in the South Island of New Zealand. And those storage or lake level managers down there want to know, what do I look like in 14 days? Is my lake full or not? And so we'll give them the 50th percentile, the ensemble mean. That's the one that pays the money most often. And they'll look at where they think their rainfall and lake levels are in 14 days' time based on the ensemble mean. Great. Then they'll also look at the 25th and 75th percentile to get an assessment of how wide that band is, what are some of the other outcomes in that group of models, and they might look at the 10th percentile, the 90th percentile. So it's all information at the 14-day mark that they can use to assess risk, okay, to make decisions on. If you just run a single weather model off the internet, you actually can't do that. I've got a bottom left, Auckland Airport rainfall probabilities used based on the same 51 member ensemble, and it shows no rain for yesterday, the Monday, but 100% rain today, and yes, indeed, it's raining in Auckland. Interestingly, the colours are actually about what percentage of models show different rainfall amounts for Auckland today, and we've got about 30% in the yellow bar band, which is the 35 to 50 millimetre rainfall in the 24 hours. It's not particularly heavy, and about half have even less than that, 20 to 35 millimetres today at the airport. The ensemble mean is around 30 to 35 millimetres today, so that's useful information for a planner, someone to try and risk assess. We also then have a week of dry before we get the next rain in roughly 7-day cycle. So gauging how much rain you get from a probabilistic sense is quite useful. Some of our clients, of course, are time sparse and time poor and just want the big picture. We do weekly, week 1, week 2. This happens to be a rainfall deviation from normal. We also handle temperature and snow and all sorts of things, where we look at this week compared to next week. Retailers really like this because they can say, I'm selling pies this week and I might be selling lemonade and beer next week. Okay, that's a rainfall map I'm showing, but you get the idea. So that was just a quick concept about why running multiple models that all initialize differently and have error at the start point, and that's okay. Talking about why you can run them in the long range into the 14-day window and how useful they are and can be in a probabilistic sense for people trying to make decisions. Now, it becomes very important, given the forum we are in, that we should talk about, obviously, if these things light up for an extreme weather event, then Met Service has a pretty good understanding of what our actual risks are in the long range and what those numbers look like. What's your 90th percentile? What's your top ensemble member? So what's the worst one we've got? It's all good information when you start to get into serious territory. So I'm just going to close there, I guess. Just to remember, please, if you take away one take-home message from today, don't run a weather model out beyond about 5 or 6 days in the Southern Hemisphere. It's not actually going to give you too much information to make decisions on. Thank you.
Great. Thank you so much, Georgina, for that really insightful synopsis of what I really sense is a perfect marriage between the intelligent use of hard technical skills and resources, and also catalyzing the kind of soft collaborative skills that we need for effective coordination and risk identification and management. That was really insightful. Thank you, Georgina. And now if we could just turn to our third speaker, who has already been wearing two hats in today's webinar, Bapon Fakhruddin, who's Tonkin & Taylor's Technical Director for Disaster Risk Reduction and Climate Change. Bapon, you'll build on what Georgina's just said and how Peter set the scene initially, and just reference, as I understand, some case studies from both Asia Pacific that will kind of illustrate a little bit more the benefits of Ensemble forecasting. So over to you, Bapon. Thank you.
Thanks, Andrew. I mean, this is quite nice integration, as you can see that the so much advancement has been made by science, but actually last 1 decade or 1.5 decade. But the point is actually why we are not able to actually fully utilize those things due to uncertainty associated with the information or the product that has been actually produced through the research or the models. Is how it could be actually more useful and usable for our decision-making process. And I think that's the major challenge that's hindering us to more using medium range or short range or long range forecasting into our decision-making, and how that could be actually produced a early warning and early action for our sectors or our specific uses. With these things, I mean, I'd just like to share one example, just showing here from Bangladesh and Thailand. Since last 1 decade, I'm actually working on this, how we can actually utilize this medium range forecasting for some of the country who quite severely affected by flooding, like in Thailand and Bangladesh. And it has been well proven. If you look at some of these forecasting tools, the model able to actually predict quite well in advance, standard in advance. The red is your forecasting and the black dot is your actually the observation. And the fundamental information that as a user we are looking for 3 basic information, which is actually when the flood will come, how big it would be, and how long it will be staying, and then when it's going to be recede. And we are not actually quite bothered about that how many centimeter, how many millimeter it's gonna be there. So if you can able to provide this fundamental 3 information, people are actually quite good to making their decision within this uncertainty. And you can see an example which has been produced by Professor Peter Webster from Georgia Tech University, that the model able to actually predict the 3 basic fundamental information, your flood onset, flood duration, and then flood recession quite accurately. And if the model able to provide that kind of information, that is fair enough to saving your lives and reducing your asset losses, even though you cannot save every asset, but at least if you can actually make your life savings, that is quite crucial at this moment for early warning systems. Other than this, there has been so much usability you can see right now in the European world with this, especially on the flooding as well as drought, hazard warning space, and also some of the epidemics and other hazard space as well. So they are providing those kind of information for decision making in the transport sector, for especially the transport maintenance, road network improvement, as well as other activities in the agriculture to understanding the agriculture production, crop selection, cropping pattern, as well as variety, livestock, pasture production, energy sector for wind power, as well as water sector for understanding the water demand and supply management. And also these are providing them quite a lot of scenario based information, so that helps them to better understand what kind of decision making they can actually take for next week or next 5 days or next 10 days. But it may vary for time to time, because the more longer horizon you go, the less actually the accurate the forecast is. I would say quite good achievement has been done by Copernicus EMS systems, some of the European Union share programs, and also some of the activities that are Southeast Asia, and especially in the Mekong River Commission, as well as the Bangladesh, Nepal, and from India actually working on it. I can also share an example from, and you can see actually, it's not only about the forecast that you actually provide. You actually need to make sure that the forecast is actually actionable. The forecast is actually demonstrating your response option. And when you're able to provide those kind of information to a non-literate people, that what does it mean to them, they actually can able to take some of the decision. On the right side, you can see that actually based on the 10 days forecast, the fisherman actually start putting the net so that his cultured fish cannot actually go other places. They also start catching fish so that actually they can sell it to the market. So an early warning using this kind of 10 days to 7 days lead time enables them to better understand what are the impact they are going to face and what would be the alternative management practice they can actually apply for their particular uses. And that's where actually it comes as a more usable and useful information for their decision making and impact-based forecasting systems. Here, just one recent example from Fiji. You may saw 2015, 2016 cyclone impact in Fiji, and there has been so many casualty on that time. Around 84 people actually died in Cyclone Winston. But look at the similar category cyclone that are happening today with the advanced technology that the Fiji Met Service has, and also the partnership and engagement with public, private, and academic. They're able to come up with this with a super sophisticated model that World Meteorological Organization providing called Coastal Inundation Forecasting Systems, which providing using a multiple model, atmospheric, ocean, and hydrological model. They are actually providing quite state-of-the-art information quite in advance for their population so that they're able to at least save their lives, and there is no casualty. You may see last 3 cyclones that happened in Fiji. So which are some of the good sign actually. You can see that how a ensemble-based forecasting could able to provide or lead to a decision-making process for the countries. And you obviously seen that as well as Georgina just mentioned, that actually the more actually lead time it goes, it doesn't have much usefulness. So you can see a track error from 6 hours to 120 hours. And then once you look at the 120 hours, it gives you a track error around 60 kilometers. But what does it mean to us? It means like if you follow 120 hours lead time, you have to actually need to evacuate your 600 kilometer bandwidth area. But if you have at least say 4 days, which is 96 hours or 78 hours, you may actually doesn't need to evacuate all your population in that range. You may be able to reduce the evacuation process from 100 kilometer, 50 kilometer, or even in 24 hours. It comes to around like a 60 to 70 kilometer area is the maximum error or maximum buffer zone that need to be evacuated. So those are the advantage here you can see. And obviously there has been a lot of potentiality. You can see that an economic benefit to having an end-to-end early warning system. So it's not a single system, it's called like a system of a system. So it doesn't only talks about the models and results, it's linking with the political will, your observation systems, your modeling capability, your dissemination process, your risk communication, as well as community preparedness. So we come up with this 10 essential elements that could enhance your overall warning systems and end-to-end, looking at how the warning has been generated to how the warning has been shared. And it has been already published some of this good research paper that if you invest $1, it could bring you a $6 benefit for Pacific for cyclone warning. But for a country like a Bangladesh or Nepal or Thailand, where you can invest $1 for a flood warning, it could give you a $40 worth benefit. But also there has been a lot of willingness by the population to receive some of this advanced information. So you can see that people are actually quite willing to spend $5 to $6 to receiving some of this information product. So that's where actually it gives a potentiality that how we better use this advanced research and advanced science for our decision-making process into early warning systems. Finally, I just like to say to leverage an effective early warning systems and disaster risk reduction, the key aspect of hydrometeorological system is we need to understand the overall value chain, and we need to understand the maturity, how mature the hydrometeor value chain and its each elements are, because each single element is equally important and equally need to be strengthened. And at the same time, how actually you do the sector balance, so how actually all the sector actually working together and how the engagement process has been made in an overall hydrometeorological chain, and then the policy and legislation as well as political will to support some of these activities for the decision-making process. So in this way, you can see that everyone actually may play a quite important role. It's not only the public, it needs to be private, it needs to be have an academic, it needs to be have a social organization or CSO as well as NGO. So, and also you can, as Peter just mentioned, that actually private sector actually playing quite dominant role at this moment, because they're providing a lot of scenario-based impact information for our users, so that enables us to making our decision making quite well. And I think that's one of the area that we need to explore, that once our national hydrometeorology services provide the warning or a forecasting, how the forecasting could be create some scenarios to enable us to our sectoral decision making, and then how that decision making could be interpreted to our community to saving lives and reduce the damage of the property. I think that's all from my side, and thank you so much for listening. Over to you, Andrew.
Thank you, Bapon, and just to say your work in the Pacific is so highly appreciated by many of the countries, and that combination of technical know-how and community connection is rare but really well appreciated. So we have 5 minutes left. Thank you to Peter, Georgina, Bapon for your insightful remarks. And also thank you to Rosalina, Wendy, Tushar, Spiros, Ramesh, Rosalina for your questions. Luke, you've just question just come in. Thank you. I'm going to try and mold them into kind of one overall sort of reflection from our participants today, and then invite each of our speakers a 1 minute concluding remark linked to that. And all of the comments and questions more or less linked to the opportunity and the challenge of communicating uncertainty and probabilities at the community level. How do we simplify some of this technical information so that if this information is understood and acted upon, is usable, useful, and used? What are those opportunities, things we should be looking at to kind of reach the so-called last mile, or indeed the first mile, depending on your perspective? So thank you, dear participants, for those questions. So if I could turn to Peter, please, for your final reflection, then on to Georgina, and finally over to you, Bapon. So Peter, over to you first. Thank you.
Well, clearly the choice of language is critical. Talking in words like there's a 20% chance of something happening means nothing to a lot of people. Saying 1 in 100 years might mean we've got 100 years before it happens again. So again, as opposed to it might actually happen tomorrow, even though it's only predicted to occur once in 100 years, doesn't mean it won't happen tomorrow. And so language is critical. Who communicates is critical. If people are seen to either have a political or a commercial lens on it, it is seen differently to if it's a neutral person like a meteorologist doing so. Thirdly, people actually do understand uncertainty if it's communicated in words that they can understand. They can understand there's a chance of something happening tomorrow or happening next week, and they can make decisions based on that. I think we need to avoid jargon. I think meteorologists have got better at doing that over recent years, but it's still there. In many other years, we don't do it. In many other areas, we don't do it well. And I would suggest, and I saw one of the questions from the Philippines asking about this, involve the people who are affected in helping draw up the communication strategy. They will tell you whether you're doing so in a way that's meaningful or not. And the last point is, get on the web, look up Sir David Spiegelhalter, and look at the world's best communicator on risk and see how he does it. Because Sir David from Cambridge is the world's outstanding communicator on these issues. And he's great to watch.
Thank you, Peter. Thank you so much for those remarks. Really addressing the question and or the questions from several very specific and useful perspectives. Thank you, Georgina. Please, could you respond to the questions? Thank you.
Sure. I better do a mic check, eh? How's my levels? Yeah.
Yeah. Okay.
Good,
okay,
checking, because I don't know what happened last time. Okay, the questions, right. Mixed messaging from multiple commentators is a real problem. So given that we're the National Weather Service, we employ 24/7 and we have all the tools and techniques and modelling, the best modelling and the best trained staff, the experts in the field, then I believe the warning system should come from the National Weather Service. Mixed messaging is our bane of our life. It just makes the public completely confused. When we go for a red warning, heavy rain warning, that red colour means we expect loss or life of infrastructure. We want to be able to clearly communicate this will be bad. Today's rainfall in Auckland is a really good example. I know not many people are from Auckland in this chat, but we had another commentator drumming on that this would be serious or severe, and that's not the case. So that's the cry wolf when someone else gets excited about what is a fairly ordinary winter rainfall event. So to be a bit careful with warning systems are, or should be, delegated to the national body who has the mandate, and we do nationally. And you won't, every National Weather Services have the mandate for national warning systems. So I don't think that there is room for 2 systems or more. I like Peter's comment around communication and risk, and that, communication is key, of course. Now, was there another question in there for me?
That was it was just an opportunity to respond en masse, if you like. Thank you. Okay, thanks, Georgina. So I just see we're a minute past our supposed finish time. So if you just please allow me to offer the floor to Bapon for his responses. Thank you.
Thanks, Andrew. I mean, to me, a last mile should need to be a first mile. So if you want to talk about the warning information, it all need to be talked about community. So everything needs to be designed based on the need-based rather than top-down. So obviously, we have a product, but we need to understand actually what is actually the demand side of it. Without knowing the demand, there is no use actually of the product, whatever product we produce at the national level. So every time we need to be working on a forecasting and warning systems, it needs to always look at people, and people. So looking at the people, their needs, their understanding, and if you can able to actually customize those things to their local dialect, local information, how they want and where they want and what kind of way they want, that would be the success for making sure that the advanced science that we are doing globally, regionally, or even at the nationally, that has some usability and usefulness at the community level. And that's the, I think, the success for us as a meteorologist or hydrologist working in this field, to bringing something which has some societal benefit and making sure that their lives are safe as well as their property is really less damaged. Thanks, Andrew.
Bapon, indeed, thank you, Sir Peter Gluckman, Georgina Griffiths, and you, Bapon Fakhruddin, for today's insightful discussion that I think really makes the case for the importance of medium-range hazard warning systems that can translate into effective early warning and early action at the community level. So just in conclusion, what we heard at the end, it's really important to avoid mixed messages. We have to mind our language, we have to trust the people, we have to involve the people, and as Ron says, it's more about the first mile than the last mile in terms of putting community needs and perceptions at the front. So on behalf of our 3 panelists today and myself, thank you very much for participating in this webinar. We hope it's provided some useful reflections for you, and we look forward to engaging with you when Tonkin and Taylor and colleagues decide to broadcast another webinar on a topical and relevant subject. So from Peter, Georgina, Bapon and myself, thank you again, and goodbye and good afternoon from Suva. Thank you.